We are asked to test the following series for convergence or divergence. So to find out whether it converges or diverges, we do not need to know the value that it converges to. And so whenever you see something that has 3 to the k, for example, you should immediately realize that that this can be tested for convergence using the ratio test. And so in the ratio test, we're asked to find rho. Okay, that's a bad one. Rho, and rho is basically the limit as our k approaches infinity of term un plus 1, so we need term un plus 1, divided by term un term. What this basically means is you have to, well, that's the rule actually in this case, it's k, because our unknown is k. So what this then transfers to is the limit as k approaches infinity of, we put k plus 1 into every k to get k plus 2 over 3k plus 1, and then divided by k plus 1 over 3 to the k. So this is k plus 1, and then 3 to the k plus 1. This you can rewrite as the limit as k approaches infinity of k plus 2 times 3 to the k, right? Outers over inners, over k plus 1 times 3 to the k times 3, because 3 to the k plus 1 is nothing but 3 to the k times 3. And then these conveniently cancel out. And so what you end up with is the limit as k approaches infinity of k plus 2 over 3k plus 3. And this you solve by L'Hopital, and L'Hopital's rule says that you can take the derivative of the numerator and the derivative of the denominator, and you're left with 1/3, because the constants go away, and you just take the coefficients of the k's. So the limit is in fact 1/3. And the rule says that when rho is smaller than 1, and in this case it is, because rho is 1/3, then the series converges. And hence, you can say that the solution to this problem is, or the answer, that we have proven that the series converges by ratio test.